In this video, we conclude our studies on kinematics by introducing acceleration and how it fits in with position and velocity. This is a continuation on the previous video on speed and velocity, so if you haven't already checked that out, then please do so using the link above. For those who don't know me, my name is Chris Inozoni. I've been tutoring for about 2 years now, and I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. Acceleration and velocity are directly related to each other. In fact, acceleration is defined as the rate of change of velocity. Using derivative notation, you would call this dv on dt, or if you're just describing it as a function, then you would call it v dash of t. Simply put, if you know the velocity equation of a particle, then you can find its acceleration equation by finding the derivative of the velocity equation. If we zoom out for a moment, we can see that position, velocity, and acceleration are all related to each other via the derivative. They are all derivatives of each other. It's also worth noting that anything related via differentiation is also therefore related via integration, or anti-differentiation. The key thing to take away from here is to know that if you have at least one of these equations, you can find the other two using either differentiation or anti-differentiation. Anti-differentiation specifically gets a little bit tough, but not by much. Let's try some examples. The most common kind of question is going to ask you to figure out what are the position, velocity, and acceleration equations. In this case, we have the velocity equation, and we have to find the other two. If we want to find position, we just need to anti-differentiate the velocity equation. When you do that, you'll notice an issue pretty quick. There's this plus c term in there that is unknown. We can always solve for that plus c term by subbing in a known point. This known point is going to come from the fact that we know that the particle starts at the origin. Starts meaning t equals 0, and origin meaning position, or x equals 0. With that in mind, we're just basically subbing in the point 0, 0 into our position equation. And when you simplify that, you'll see that c will also come out to be 0. Now that we have that, we can move on to finding the acceleration equation, which I mentioned earlier is just the derivative of velocity. Differentiation is a bit nicer here because there's nothing else we need to do. We've got the equations we need. Sometimes you'll be asked to find the initial state of your scenario. This could be the initial position, velocity, or acceleration, or even all three. In any case, finding the initial value of something just means subbing in t equals 0, since that's where time equals 0. It's the initial state of your scenario. If we do that for all the equations, we're going to find that the initial position and velocity are 0, and the initial acceleration is going to be 2 meters per second squared. The question now becomes, how do you interpret this? Well, let's go line by line. If the initial position is 0, then it means we're starting at the origin. If the initial velocity is 0, then it means we are at rest, we're not moving. And finally, the initial acceleration of 2 meters per second squared means that we have momentum pointing towards the right, since once again positive means going to the right and negative would mean going to the left. We can then put this all together by saying that the particle starts at the origin, at rest, and it's about to move to the right at an acceleration of 2 meters per second squared. Average acceleration is actually a bit nicer than doing average speed or average velocity, and this is because there's only one equation to memorize. Acceleration is only ever going to use velocity as part of its equation. There is no speed equivalent. So let's try to find the average velocity. Nothing fancy here, we're just going to figure out what our interval is and then plug it into our equation. In this case, we want to find the acceleration over the first 5 seconds, which means from 0 to 5. So we're just going to sub in the upper and lower bound into our function and then just simplify the results. And that's going to give us an acceleration of 102 meters per second squared. Acceleration is a bit of a weird quantity, and that's because you can't interpret it in isolation. You also need to consider what the velocity is doing. Let's look at a few scenarios. The first case is if your acceleration and velocity are going in the same direction, then you are considered to be accelerating. For example, if your velocity and acceleration are both positive, then it means your particle is moving to the right and it's getting faster. Hence, you would be considered accelerating to the right. Alternatively, if the velocity and acceleration are negative, then you're moving to the left and getting faster to the left. Hence, you would be considered accelerating to the left. So even though acceleration is negative in the second example, both of those scenarios are considered acceleration. The only difference is what direction you're accelerating in. The second scenario is if your velocity and acceleration are pointing in opposite directions. Under this scenario, you are considered decelerating. For example, if your velocity is negative but your acceleration is positive, then it means that your particle is moving to the left, but it's getting slower over time, and eventually it'll stop and then turn all the way around back to moving in the right direction. If we assume some numbers, we could explain this scenario by saying that the particle is moving to the left, but it's decelerating at a constant rate of 3 meters per second squared. It's just the same thing as the brakes on a car. Imagine a car is driving towards the right at some velocity, let's call it 60 kilometers an hour. As soon as you put on the brakes, you slow down. You don't just immediately stop. That slowing down is a deceleration, and as far as the math pans out, it just means that you're applying acceleration backwards in the other direction. So to summarize, if your velocity and acceleration are pointing in the same direction, then you are considered accelerating. But if your velocity and acceleration are pointing in different directions, then you are considered decelerating. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool. You should check it out. I'll see you there.